Hello everyone, how are you all today? I'm back with another video, and in this video I'm going to teach you how to convert non-terminating but repeating decimals to PYQ form. So let's get started. In my last video I explained to you that there are three types of decimal numbers, that is terminating, non-terminating but repeating, and non-terminating non-repeating. And I also explained the difference between each of these types. So if you have not watched that video, then please watch it before watching this video. You do not need to watch the whole video, you just need to watch a small part of it. You just need to watch a small part of it from 15 minute 35 seconds to 28 minute 12 seconds. So only this much of video you need to watch. So from here on I will assume that you have watched that video, and I will not explain the things that I have already explained there. Students, our today's topic, that is the conversion of non-terminating but repeating decimals to P by Q form. Okay, now the question is, why do we need to do it? Why do we need to convert non-terminating but repeating decimals to P by Q form? Okay, so this is the first question that you need to ask yourselves. Okay, so the answer to this question is that in my last video I told you that both terminating and non-terminating but repeating decimals are rational numbers, and you know that a rational number is a number that can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. And since non-terminating but repeating decimals are also rational number, so we can convert it in the form of p by q. And how, that is we are going to learn in this video today. Okay, now before I start teaching you the method of conversion of non-terminating but repeating decimals to P by Q form, I need to tell you what is non-terminating but repeating decimals. So let's have a look. Now, in order to understand non-terminating but repeating decimals, let's convert 5 by 3 into its decimal form. Okay, so let's convert 5 by 3 into its decimal form. For that we will divide 5 by 3. Okay, and 3 times 1 is 3 and remainder is 2, and taking one decimal in the question we can put 1 0 over here, and now it will become 20. So 6 times 3 is 18 and the remainder is 2, and again we can put 1 0 here, and 6 times 3 is again 18 and again the remainder is 2. So you can see that no matter how many time I continue with this division, I will again and again get remainder 2, and because of this 6 will keep on repeating in the question. Okay, so you can see that my remainder is never becoming 0, and I am getting same number 6 in the decimal again and again. So what I will do, I will write 5 by 3 is equals to 1.6 bar. Okay, and this bar indicates that this 6 is being repeated infinitely many times. Okay, and these types of decimal numbers where your remainder does not become 0, and in your question a single or a 2 digit or a 3 digit may be repeated infinitely many times, so that type of decimal numbers are known as non-terminating but repeating decimal numbers. The non-terminating but repeating decimals are further divided into two parts, and that is pure repeating decimals and mixed repeating decimals. Now what is pure repeating decimals? So if in a decimal number every digit after the decimal is being repeated, so if every digit after the decimal is being repeated, then the decimal number is known as pure repeating. For example, you can see that 0.4 bar. So you can see that there is only one digit after the decimal, that is 4, and the 4 is being repeated infinitely many times. This means this is a pure repeating decimal number. Again 1.6 bar. So there is only one digit after the decimal, that is 6, and the 6 is being repeated infinitely many times. In the next example, you can see that there are 3 digits after the decimal, that is 394. Now all these digits, that is 394, is being repeated. So this is also an example of pure repeating decimal number. Now what about mixed repeating decimal? So if in mixed repeating decimal number, not every digit after the decimal is being repeated. For example, you can see that 3.597. So you will see that there are 3 digits after the decimals, that is 597, but out of these 3 only 2 are being repeated, that is 97 is being repeated, whereas 5 is not being repeated. So this is an example of mixed repeating decimal number. Again 0.32 bar, you can see that there are 2 digits after the decimal, that is 3 and 2, but out of these 2 only 2 is being repeated. Again in the next example, that is 42.8759, only 759 is being repeated, whereas 8 is not being repeated. So these are the examples of mixed repeating decimal numbers. So this was very important for us to understand what is pure repeating and what is mixed repeating, because we will be making use of these two uh, types while converting non-terminating repeating decimals into p by q form. Now we have all the necessary information that we need to convert non-terminating but repeating decimals to p by q form. So now we can move to the conversion part. So let's see how you convert non-terminating but repeating decimals to p by q form. Our first question, we need to express 0.7 bar in the p by q form. Okay, so let's see how to do it. Okay, so the very first thing that you need to do is that you need to make sure that if this is a pure repeating or a mixed repeating number. So we know that there is only one digit after the decimal, that is 7, and 7 is being repeated, and this means that this is a pure repeating decimal number. So once we know that this is either this is pure repeating or mixed repeating, then we can proceed with our solution. And you see there are different ways of solving both these types of decimal number. If you have a pure repeating, then we will use different approach, and if we have mixed repeating, then we will use a little different approach. Okay, so the approach that we are going to use right now is for pure repeating. So what we will do is we will write this 0.7 bar equal to x. So I write this 0.7 bar equal to x. Now why I did it, you see that I told you that 0.7 bar is a rational number, and if it is a rational number, then I can write it in the form of p by q. So I assume that the p by q form of 0.7 bar is x. Okay, so I do not know right now, I don't know what is the p by q form of 0.7 bar, so I assumed it to be x, equal to x. So I write it 0.7 bar is equals to x. Now what I need to do is I will write x is equals to, I will remove the bar and I will repeat 7 three times, and then I will put three dots. Now why I did it, you see the digits which carry bar, I will have to repeat it at least twice. Okay, so I will remove the bar in next step, and I will repeat the digit under the bars at least twice. So you can see that I have repeated it three times. You can repeat it two times as well, but not less than two times. Okay, so take care of this. Okay, now I will write this is equals to equation 1. Now what I have to do? Now I will multiply equation by 1 by power of 10. I have to multiply equation 1 by power of 10. But what power of 10? Okay, so what power of 10? What should be the value of not x, let's say y. So I have to multiply it by power of 10, but what power of 10? So from that we can find out by looking at the number. Okay, so you can see that there was only one digit after the decimal that was being repeated, and that is 7. So you have to multiply by power 10 to the power 1. So how, what power of 10 you can find out using how many digits after the decimal is being repeated. So since there is only one digit after the decimal is being repeated, it means I will multiply by 10 to the power 1. So I will write multiplying equation 1, multiplying equation 1 by 10. Okay, 10 to the power 1 is equals to 10. So our equation 1 will become, on the left hand side we have x, so 10 times x is what? 10x. On the right hand side I have 0.777 and so on. So if I multiply it by 10, it will become 0.77. And you see that here I have written 7 three times, so here also I have to write it at least three times. You see there are infinitely many sevens after the decimals, and every time I have to write it at least three times or two times. So in our previous step I write it three times, so in next step also I will write it three times. If you write it two times, your answer will be incorrect. Okay, now this is my equation 2. So I will represent this by equation 2. Now what you need to do is you need to subtract equation 2 from 1. So we will write subtract 2 from 1, not 2 from 1, 1 from 2. Okay, so take note of this. Okay, you have to subtract 1 from 2 and not 2 from 1. You have to subtract 10x minus x and not x minus 10x. So 10x minus x. So 10x minus x, and on the left hand side we have 7.777. So we will write 7.777 dot minus, in equation 1 we have 0.777. So I will write 0.777 dot. Now subtract it. So on the left hand side I will have 9x, and on the right hand side I will have what? I will have 7.000 dot dot dot. Okay, because you see that there are infinitely many sevens here as well and here as well, and all those sevens will subtracted and we will get 0. So we will get infinitely many zeros after the decimals. So we can write it like just 7. So 9x is equals to what? 7. Now we assume that x is the p by q form of 0.7 bar. Okay, we assume that x was the p by q form of 0.7 bar in the first step only. Okay, so now we have to find the value of x. So x is equals to 7 by 9. So this is our p by q form of 0.7 bar. So this was a one way of doing it, but there is actually another way of doing it, and let me tell you, and that is actually a short trick. You can say that that is a short trick. So let me tell you that short trick. So for doing it in a very simple way, what you have to do is you just have to remove the bar and write the digit under the bar in the numerator. Okay, so the digit under the bar will be written in numerator, and how many digits were there under the bar? So you see that there are only one digit after under the bar. Okay, we can see that there is only one digit under the bar. So only one digit under the bar, so we will write that many nines in the denominator. Okay, so since there is only one digit under the bar, I will write 1 9 in the denominator. So the digit which is below the bar will be written in the denominator, and that is 7. So I write 7 in the numerator, sorry, not denominator, numerator. So the digit below the bar is written in the numerator, that is 7. And how many digits are there under the bar? And that many nines are written in the denominator. So since there is only one digit under the bar, so I will write 1 9 in the denominator, and this is the how you write the p by q form of a pure recurring decimal number, pure recurring, or you can say pure repeating decimal number in short trick. Okay, so this was the short trick of doing it. Let's do few more questions and then we will be clear about the method. Okay, so these are the two more methods that you can follow. Take note of these two methods. So this was the first method, and the method I just showed you is the second method, or you can say a short trick. So I want you to write both of these method. Okay, so take a screenshot of this, now this as well. Now let's do few more questions and then it will be clear to us. So this is our second question, and here we need to express 0.23 bar in the p by q form. So again we will first check that if it's pure recurring or mixed recurring. So this is our pure recurring, since there are only two digits after the decimal and both the digits are being repeated. So what I will do, I will write this equals to x. So 0.23 bar equal to x, and this means that x is the p by q representation of 0.23 bar. Now what I have to do, I just remove the bar and repeat the digits under the bar at least twice. So I will repeat it 3 times just to be safe. Now what I have to do, I have to multiply by power of 10. Now what power of 10? So how many digits are below the bar? I can see that there are 2 digits below the bar. It means I have to multiply by 10 to the power 2. So I will multiply this, I will write it as equation 1. Now I will write multiply equation 1 by 10 to the power 2, that is 100. So I will get what? On the left hand side I will have 100x, and on the right hand side I will have 23.23. So again I want you to note that you need to write 3 times. You need to repeat 3 times. Okay, so earlier I have repeated 3 times. Here also I will repeat 3 times. Otherwise if you repeat only 2 times in the next step, your answer will be incorrect. So take care of this. Okay, take note of this, otherwise you will make mistake. Now I will write it as equation 2. Now what I need to do is subtract equation 1 from 2. So I will subtract equation 1 from 2 and not 2 from 1. Okay, so if I subtract equation 2 from 1, what I get? I will get on the left hand side I will have 100x minus x, and on the right hand side I will have 23.2323 23 dot 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 minus 0.232323 dot dot dot. Now in the left hand side I will have 99x, because 100x minus x is 99x, and on the right hand side I will have 23.000, infinitely many zeros, because there are infinitely many 2 3's, and all those will cancel out in subtraction. So I will have 99x is equals to 23.000, so on. So I can write it as 99x is equals to 23 only, and then x will become 23 by 99, and we know that x was the p by q representation of 0.23 bar, and now we have obtained the value of x, that is 23 by 99, and this means that p by q representation of 0.23 bar is that 23 by 99. Okay, now let's do it using short trick. So I told you in short trick what you do is, let's write the number first. Okay, so in short trick what we do is we remove the bar and we write the digit under the bar in the numerator. Okay, and this short trick will only work when you have pure recurring decimal number, pure repeating decimal number. So this is pure repeating, so we can use short trick here. So I can write 0.23 bar, so I will write 23 in the numerator, and in the denominator I will repeat how many digits after the decimal were being repeated. So since there were only two digits which were being repeated, so since there were only two digits under the bar, so I will write two nines in the denominator. So both of these answers are actually same. So this is how you do it using a short trick. So I hope you understand it. Now let's do one more question, and we will use just short trick this time. Okay, we will solve more question but only using short trick. So let's solve 0.437. So let's convert this into p by q form using short trick. So first, in order to apply short trick, first thing that we need to make sure is that if it is pure recurring or mixed recurring. So this is pure recurring, and why? Because every digit after the decimal is being repeated, so this is pure recurring. Now in order to convert it in the form of p by q, what we will do, we will remove the bar and we will write the digits under the bar in the numerator. So there are these digits are there in under the bar in the numerator. Okay, so 437 are under the bar, so we write 437 in the numerator. Now how many digits are under the bar? So since there are three digits which are under the bar, three digits means three nines in the denominator. So this is the p by q representation of 0.437 using short trick. Now let's do one more question only. Okay, so this is little bit unique, that's why we are doing it. Okay, now we have to represent 18.48 in the p by q form and just using short trick. Okay, so first thing that you need to do is make sure if this is pure repeating or mixed repeating. So you see that every digit, that is there are only two digits after the decimal, that is 48, and both of these digits are being repeated. It means this is pure repeating, and if the number is pure repeating we can apply short trick. So what does that short trick says? You no, we cannot apply short trick here, because see, there is a number before the decimal as well. So we have 18.48. So first of all we need to remove this 18 from the before the decimal. So what we can do is I can write 18.48 bar is equals to what? 18 plus 0.48 bar. So I can write it like this. Okay, now I can apply short trick because I have 0.48 and this is pure repeating. 0.48 is pure repeating. Okay, so 448 by 99 using short trick. Why this? Because 48 was below the bar, so 48 in the numerator, and how many digits were there in below the bar? So there were two digits, it means two nines in the denominator. Okay, now let's take the LCM of both of these. So LCM will be 99, and since there is one below 18, so I will have to multiply 18 by 99. 18 times 99 and plus 48. So this would give us answer 18 times 99 plus 48 by 99. Okay, so if you solve it you will get the p by q representation of 18.48, and that would be equal to 1830 by 99. Okay, so you can solve this particular expression and you will get this as answer. Okay, so this is how you convert non-terminating but repeating decimal if it is pure recurring into decimal form. Okay, now uh, let's move to the case when we have a mixed repeating decimal number. Okay, so let's see how can we convert a mixed repeating decimal number into p by q form. So this is our next question, and here we have to express 0.2562 bar in the p by q form. Now you can see that this number, this is a non-terminating but repeating decimal number, and this is a mixed repeating decimal number because there are 4 digits after the decimal, that is 2562, and out of these 4 digits only 2 are being repeated, that is only 62 is being repeated. So this is an example of mixed repeating decimal number, and we have to convert it in the form of p by q. So let's see how we can do it. So again, what we will do, we will write it equal to x. So this is the solution. So first thing that you need to do is you will have to write this equal to x. Okay, now why I write it equal to x? Because I assume that x is the p by q form of this uh, decimal number, and since x is the p by q form, so I can write it equal to x. Okay, now what you need to do is you need to see how many digits are not being repeated. So earlier we used to see that how many digits were being repeated. Here we will see that how many digits are not being repeated. So we can see that after the decimal there are two digits which are not being repeated. Okay, so there are two digits which are not being repeated. So what we will do, we will multiply by 10 to the power 2 because two digits are not being repeated, so we will multiply 10 to the power 2. We will assume this as equation 1. Now we will do multiply equation 1 by 10 to the power 2, which is equals to 100. Why 10 to the power 2? Because here two digits after the decimal is not being repeated. So observe the difference in both the case. Earlier we used to see how many digits were being repeated, and according to that we used to multiply by power of 10. But here we are doing little bit things differently. Here we are seeing how many digits after the decimals are not being repeated. So there are two digits and we are multiplying by 10 to the power 2 because two digits are not being repeated, and that's why we are multiplying by 100. So we will have 100 hex on left hand side, and on right hand side we will have 0.62 bar. So this is why we did it. See, I wanted to take the digits which were not being repeated before the point. Okay, so by multiplying by 100, what I did, I was able to take this 5 which was not being repeated before the point. So this is why I multiplied it by 100. So this is what you need to do it. What you need to do, you need to see how many digits are not being repeated after the decimal in case of mixed repeating decimal number, and then you need to multiply that many power of 10. So 100x is equals to 0.2562 bar. Now from here on things are very simple. What you have to do is just write 100x and break it. So I can write it like 25 plus 0.62 bar. Very simple. Okay, very obvious. You can obviously write it like 0.62 bar plus 25. Now apply the short trick. That's why I taught you short trick, because this is very useful. Okay, so if we apply short trick here, we know that this is pure recurring. Okay, because there are only two digits after the decimal and both the digits are being repeated, so this is pure recurring. Okay, now we will apply the rule here. What was the rule? Just write the digit below the bar in the numerator, that is 62 in the numerator, and in the denominator we will write that many 9, the number of digits which are below the bar. So there are two digits below the bar. Okay, so that many 9s in the denominator, so 2 9s in the denominator. Okay, now solve it. So and you will get your answer. So 25 times 99 plus 62 divided by 99. See, there was 1 here, so I took the LCM, so LCM is 99. So I will multiply 25 by 99 and then plus 62 to it. Okay, now solve it further. So on solving it further, I will get what? I will get it equal to 2537 by 99. You can solve it using you can solve this expression and you will get this. Okay, now I will take 100 to the right side, so I will this will become like this. Okay, so 2537 divided by 9900. So this is the P by Q representation of 0.2537 bar. So this is the P by Q representation of 0.25, no 25 not 37, 62 bar, sorry. So this is the P by Q representation of 0.2562 bar. Okay, so this is how you solve when you have, this is how you represent when you have a mixed repeating decimal number in the P by Q form. So this method we are going to use. Now let's do one more question, and with this question we will end our video. So now we have to represent 32.1235 bar in the form of P by Q. Okay, so we have to represent this digit in the form of P by Q. So again, first thing first, you need to make sure if this is pure recurring or mixed recurring. So we know that this is mixed recurring. Okay, so again we will write it equal to 32.1235 bar equal to X, because we assume that X is the P by Q representation of this number. Okay, now you have to see that how many digits after the decimal which are not being repeated, because this is the case of mixed repeating decimal number. Okay, so how many digits after the decimal is not being repeated? So there are 2 digits. So we will multiply equation 1 by 10 to the power 2. So 10 to the power 2 से अगर आप multiply करोगे तो you will have 100x, and on other side you will have 3212.35 bar. Okay, now solving it further, we will get 100x, and I can, on this side I can write it like this: 3212 plus 0.35 bar. Now 100x is equals to 3212 plus 35 by 99. And how I did it? Because I know that this is a pure repeating number now. Okay, pure repeating decimal number, and since this is pure repeating decimal number, I can apply the rule. I will see what are the digits below the bar, and that digits I will write in the numerator. So 35 is below the bar, so I will write 35 in the numerator. And how many digits are there below the bar? So there are 2 digits, so that many nines in the denominator. So 99 in the denominator. Now solve it. So on solving it, it will be something like this: 99, 35 plus 35 divided by 99. Okay, now if you solve this expression, you will get 318023 by 99. And if you take 100 on the right side, you will have 318023 by 9900. So this is the P by Q representation of 321235 bar. Okay, so this is how you convert a mixed repeating decimal number to P by Q form. Okay, so I hope you like this video. Okay, I hope you understand everything that I have taught you in this video. So what you need to do is you need to solve some questions from your book, and you need to check that if you are getting things correctly or not. Okay, you will have to do some practice as well. Okay, so just after watching this video, take out your book and solve some question from the book. Okay, and this is everything that you need to know, okay, about the conversion of non-terminating repeating decimal to P by Q form. So if you have understand all this now, you will not have any problem solving any other questions as well. Okay, so thank you very much. If you like this video, then share it with your friends, and please like my video and subscribe to our channel. I will keep on bringing such contents for you people. So thank you very much. Let's see you in the next video.